Hi everyone, how are you? Welcome to the Introduction to Engineering course. Today we are going to cover chapter 8.6 through the 8.11 Universal Unit. Last week we covered what is the force and what is the density. Today we will look at more details about what is the pressures, gas pressures, as well as some efficiency concept. Before we go into the chapter 8.6, I'd like to give you some information that I have thought about the grading systems. Let me review the previous grading systems and the revised grading systems. The previously, I mentioned this in our first class. There are two grading systems. One is the relative grading system, which is based on your ranking, and the other one is the absolute grading system, which will be based on your the score out of 100%. Like I said, I will choose whichever grading system is preferable for you. So, for example, if your score is very low, but your ranking is pretty high, then I will choose relative grading system so that you get a better letter grade. On the other hand, your ranking is very low, but your total score is pretty high. In that case, I will choose absolute grading system so you get a better letter grade. But thing is, the university is still debating about the letter grade system in the current situations because they consider your some students may not have some the access to the internet services, or some students have struggling about the previous grading systems, so they thinking about the past pair systems, but I haven't received any announcement from the university yet. So if there is any change required that requires is requested by the university, then we will think about the past pair systems. But right now, I would like to maintain the current grading systems. You can see that there are points for each sections. Like homework has a 10%, and the quizzes is 15% for the standalone student and 10% for the learning community student. Remember that the learning community student, the rest of the 5% grade, your grade is directly coming from the Professor Rachel Johnson's. Like I said, I will try to keep these previous grading systems, so there will be no confusions. But if you have some concerns about this grading system, please email me. My email is right there. So anytime you can email me if you have any concerns about the materials, about the grading system, please email me. Then we can consider to change the grading system. But this grading system will apply to all the students. It must be fairly designed to evaluate fairly for all the proponents of all the students. Luckily, we have a record about your attendance from January 21st to the March, so that would be pretty sufficient for the evaluating your attendance. But course folder, you cannot submit your course folder at the end of the semester. So in this case, why don't you take a photo about your quizzes and midterm exam one, just to take the let me see. Oh, I think I couldn't give you the midterm exam one. Okay, so never mind the midterm exam one. just take the photo, the quizzes that I gave you, and email me so that I can count it as a course folders. Even though you don't have the, if you lost the quizzes, that's pretty okay. Okay, I understand. But just email me. Okay, just email me. If you missed some quizzes, then just explain to me how you lost the the quizzes. Lab assignment, now it's gonna be the fully homework assignment. Okay, so you don't need to come to the lab, so you can finish the work within 1 week at your safe places. Other exam is gonna be the online exam, so it's pretty open book test. It's a pretty open book test. Question style is gonna be either multiple choice question or mixed fill in the blank questions. Exam date, this is important. Exam date should be either Monday at noon or Monday at 2 p.m. because that was our previously regular class hours. So I want to keep our regular class hours, and don't worry about the exam hours because I will announce this exam date a week before, at least a week before the exams. So you don't need to worry about that. Suddenly quizzes are popped up and you don't know what should I do. Don't worry, I will announce there should be a midterm exam or final exam next week, so you get prepared. After finishing any homework assignments or midterm or final exam, it would be great if you take a photos of your solving process, which is a handwritten solving process, and just email me so that I can consider your solving process and give you the partial credit. Without seeing your solving process, and if your answer is not right, then it's really hard to give you the partial credit. So since we are changing the lecture format to the fully online, please submit your solving process to me via email. The last thing is the exam hours. Previously, the older quizzes is tended to have I asked you to solve the quizzes for like 10 minutes, but 10 minutes now is too short. And I know this is the online exam, so you need more flexibility compared to the face-to-face lectures. So I'm thinking that we can multiply 1.5 times for the quizzes and the midterm and the final exam. So for example, the midterm exam previously was a 50-minute midterm exams, but from now on it's gonna be the not it's 100, no, it's gonna be the 75 minute exams. Okay, so if you have any concern or questions about these grading systems and the exam hours, anything, just email me. So the last time we look at what is the mass, weight, and force, density, amount, and the temperature. Today we will cover the rest of 5 different units for pressure, gas pressure, energy, power, efficiency. Okay, and then we will have a little glimpse to see what is the Microsoft Excel. I think everyone have an experience using the Excel. Okay, so let's look at the pressure first. Okay, so what is the pressure? Pressure, the definition of pressure is force acting over an area. Okay, so here you can see the force is Newton, or it can be pound force. The area, it can be many different many different units, such as centimeter, square, meter square, inch squares. But here the interesting is they are all square. Okay, so area is always length times width. So there is square. SI unit for pressure is Pascal. So you can see force over the area. So Newton is force and the area, so, meter square. So this is the image that when I was in the University of Michigan, we tried to build a very comfortable driver seats in terms of pressures. So think about if you have high pressure on a certain your body, then that part can get easily fatigued. So we try to avoid that issues. We try to distribute the overall pressures well distributed and well balanced, and try to avoid any high peak points. Okay, so we used this pressure mat. These are two pressure mat. This is manufactured by X Sensors, which is a very expensive one. I guess it's 10,000 US dollar per each pressure measurement tool. But anyway, here is the subjective seating pressures. This is subject and this is pressure when they sit on this driver seat. Alright, anyway, this is the pressure, but we have 4 different pressures: air pressure, hydrostatic pressure, total pressure, and gas pressures. So we are going to see one by one. Let's look at the air pressure first. So here you can see the unit is ATM, PSI, which is most familiar with the PSI, the Pascal, and the millimercury. Okay, so weight of air above us. Let's look at the air pressures. So think about like this: we are living on Earth, and actually there are pressures, but we can't recognize. There is air pressure, which is 14.7 psi, because the air has weight. So there is a pressures. But our body system is exactly same as the air pressure system, so we don't feel that much pressures. But if we go deeply into the water or submerge the water, then we can realize there is high pressures. Okay, but that is hydrostatic pressure. But right now we are looking at the air pressure, 670 millimeter mercury, which is the same as the 14.7 psi, but unit is quite different, and the number is also quite different. The millimeter mercury is when we give some air pressure on a certain here you can see the mercury go increase because of these air pressures. Then we can read the length, how much mercury increased in the vacuum. So that is the how much 760 millimeter, that much the mercury go up, increased. And the another one is the Pascal. Pascal is here 1013 hectopascal, which is the standard. When we standing at the sea level, this is the standard. But if you think about the hurricane, in the center of the hurricane, the air pressure is quite low. So probably you know the wind, where the wind came from. The wind is always came from the high air pressure to low air pressures. So that is the direction of the wind. Okay, so that's why the Hurricane Matthew made 140 miles per hour, the maximum the wind speed. Okay, it's very huge speed. So let's look at the small video, short video.
Measuring air pressure. Consider a simple glass U-tube, commonly referred to as a manometer, partly filled with a liquid, for example mercury, but open at both ends. pressure acting on the fluid is atmospheric. Because the atmospheric pressure is equal on both sides, the fluid is not displaced. But if one end of our U-tube is attached to some pressure source, and that pressure is higher than the atmospheric pressure, it'll push the fluid to one side. The difference in fluid levels is proportional to the pressure in the balloon and becomes our means of measuring pressure. We can measure this difference and express the air pressure in the balloon in inches of mercury. This is just one standard unit that is used for pressure measurement. In this example, we measure the pressure in the balloon and find it to be 3 inches of mercury. When measuring pressure, we must use different liquids for high and low pressures. Liquids with higher densities will displace less for a given pressure. Therefore, a liquid such as mercury is better for measuring high pressures, and we would express these measurements in inches of mercury. For better precision at lower pressures, we would fill the manometer with water and express our measurements in inches of water. For the purposes of measuring the relatively low pressures in ductwork, water is more suitable. To gain even more precision, we often make use of a slightly different type of manometer called the inclined manometer. It works more or less the same as the U-tube manometer, but one of the columns is placed at an angle, therefore making the scale easier to read. A water-filled inclined manometer is used to measure very low pressures in HVAC systems.
Alright, then what is the absolute pressure? Absolute pressure, they use the perfect vacuum condition as a reference. So think about right now, so as I said, we are living on Earth, and the Earth, on the sea level, there is air pressures. Always there is air pressures. But if you think about in the space, there is no air pressures because there is no air. The thing is, the absolute means we can consider the vacuum condition as a reference. So what we're going to say is, when we measure the tire air pressure on a certain area, then this tire pressure is 35 psi-G. This G is meaning of gauge. Okay, so we measure the pressure, tire pressure, using this gauge, and plus there is air pressure. So at the sea level, your tire absolute pressure is 49.7 psi. A absolute means A, psi A. But at the 12,500 feet above the sea level, like Lake Titicaca, it's very highest levels compared to the sea levels. The absolute pressure should be same, but the air pressure will be low because of the high altitude. Less air because it's a high altitude. Then your tire air pressure will be increased, so your tire will become more bigger because of this pressure. Then let's look at the hydrostatic pressures. Pascal's law. If you dive deeply, then you will get more pressure. Based on this Pascal's law, the hydrostatic pressure is equals to rho, which is density, times g, which is gravity, times height. The height is how much depth you dive into the water. So here, as I said, the pressure is force over area. Okay, the pressure is force over area. The force is weight. So the weight is mass times gravity. Okay, then what is the law? Law is mass divided by volume, right? So we can say like this, and then the volume is area times height. So here we can get rho. That means the density of water, and the gravity is 9.8 meter per second square, and the height, how much dive you deep into. So there's only three factors: rho, gravity, and the height. Okay, And I found that the article said if you dive more than 20 meters, then you would feel like a drunken. That is, we call it martini effect. Okay, when you drink like a martini, drink 1 cup of martini, then you will feel drunk. Then it's same feeling when you dive 20 meters deeply, then you will feel the same way. So let's look at let's calculate the hydrostatic pressures only in this time. So a diver dive the water, let's say go 20 feet. Okay, then what is the hydrostatic pressures? The hydrostatic pressure is the water is 1000 kilogram per cubic meters. Gravity is 9.8 meter per second square. Let's assume that. And the height is 20 feet, which is 6.1 meter. So here we can just simply multiply these three things. Then we can get it around 59 kilopascal for the hydrostatic pressures. But we have to think about the total pressure. What is total pressure means? The total pressure, let's see the small video here.
Or we experience about 14.7 psi of atmospheric pressure. We refer to this type of pressure as static pressure. When the wind starts to blow, we have to deal with the added force due to the speed of the wind. We call this pressure the velocity pressure. The sum of the static and velocity pressures equals the total pressure.
Okay, so the total pressure means no matter what we acting or moving or diving around, there is a pressure, which means static pressure, and that static pressure comes from the air. Okay, so air is always existed. That is static pressure, and the plus if there is a wind or if we go dive submerged more deeply, then if we go deeply dive, then hydrostatic would be increased. That kind of dynamic pressure we call it velocity pressures. Okay, so when we calculate the total pressure, we have to sum up those static pressure plus the velocity pressure. So total pressure of diver is there are the waters and we have air pressures. So here you can see there are air pressure plus hydrostatic pressure. That is the total pressure of the diver. The air pressure is around 1000 hectopascal plus the hydrostatic pressure, as we calculated before, it was around 60 kilopascal. So we sum up these 2 pascal and we can convert it to ATM. 1 ATM is around 100 K pascal. So that is 1.59 ATM. If you think about on the sea level, the ATM is only 1, right? But if you go dive, it's 1.59 times higher pressure than you stand in the on the beach. Okay. Then what is gas pressures? Let's look at the short video.
The independent gas particles inside a slightly deflated basketball collide with one another and the walls of the basketball, causing pressure. How could you raise the pressure in the ball? You could add more air particles to the ball. As the number of particles increases, so does their number of collisions per second with the wall of the basketball, which first pushes out the walls of the ball and then raises the pressure. You can also alter gas pressure by changing the gas temperature. Warming up the basketball causes the gas particles to move faster. The faster moving particles collide more frequently with the wall of the basketball, causing a rise in pressure. As the gas pressure increases, so does the volume of the ball, until eventually the ball explodes.
I think this is a very good video to explain what is the gas pressures. So here you can see the ideal gas law. P is a pressure and V is volume and N is amount. So amount from the chemistry, and R is a gas constant. Here is the constant, and the T is temperature. So what I'm going to say is that the gas pressure is a little bit different compared to other total pressure, hydrostatic pressure, because this gas pressure is affected by temperature. So if you get more, increase the temperature, then you can see if you increase the temperature, then volume and the pressure will be increased. If you decrease the temperature, then volume and the pressure will be decreased. Alright? And if you add more amount of the gas, then it obviously increases the volume and the pressures. That's the concept. Let's look at the energy. Energy is think like this. Energy is force times distance. Okay, and it's always the same. There is a force, and if you exert the force for a certain distance, then it's work. So work is energy. Okay, same. The potential energy is if we lift up a chair for a while, and there is a weight and height. That is energy. That's how much energy we need. But if there is a time, then that is we have to consider as a power. But we will see that things in the next slide. But anyway, here we have 4 different type of energies: work energy, potential energy, kinetic energy, and thermal energy. Okay. So let's look at first about the potential energy or work. It's the same. So let's say we have a 50 kilogram load, like a table or some very big computer or some chairs, whatever, and we want to raise it up vertically using this machine for 5 meters. Okay, in this case, then how much energy do we need? Okay, we have a 50 kilogram load. We want to raise it vertically for 5 meters. So potential energy is weight times height. In this case, the weight is mass times gravity. So 50 kilogram times 9.8 meter per second square times 5 meter. So that is 2,450 kilogram meter square per second square. So this is joule actually. So 2,450 joule. How about the heating energy? Have you heard about BTU and calorie before? BTU stands for British Thermal Unit. What is meaning of BTU? BTU is amount of heat energy required to increase 1 Fahrenheit of 1 pound of water. Okay, so BTU, we have 1 pound of water. If we want to increase this 1 pound of water by 1 degree Fahrenheit, that is 1 BTU. The 1 calorie is we want to increase the 1 degree in Celsius of 1 gram of water. So let's look at some examples about the BTU, hot coffee. People like drinking the hot coffee, approximately 70 degrees Celsius. So let's assume we have coffee, the mass is 470 grams of coffee. Okay, we have this amount of coffee, and then we want to raise this coffee by 30 degrees in Celsius. The delta T is 30 degrees, and the mass is 470 grams, and the CPC is a constant for it depending on the material, but let's assume it was given by 4.18 joule per gram Celsius degree. Okay, so we can just simply multiply these 3 things. then we will get 446 BTU. Okay. So HVAC stands for heating, ventilation, and air conditioning industry. Okay. How much BTU we need to warm up the air in a certain amount, certain space area. If the room or the place is big, then we need more BTU to heat up the air. So that's how we found it. Okay. And the calorie versus calorie. I usually go to Subway to have a Subway sandwich, and they always tell us, okay, this turkey sandwich 6-inch long has 330 calorie and 670 calorie. So as I mentioned that before, the definition of the calorie is increasing 1 degree of Celsius of 1 gram of water, right? But here you can see a little difference between the lowercase calorie and the uppercase calorie. So here, what you can find is carbohydrate. It contains 4 calories, which is 4,000 calories. That is 4 kilocalories. So here you can see there are differences. We have to multiply 1,000. Actually this is kilocalorie. All right. And let's see the power. Power is energy per time. So the SI unit is watt. Okay. So if you see this watt, energy divided by time. Think about the last case example. If we want to lift up 50 kilogram chair for 5 meters, then we need this much of potential energy. But if we want to lift very quickly, then we need more power. For example, we want to lift in 60 seconds. 60 seconds. We just to divide it. Then how much power we need? We need 41 power. But if we want to lift more fastly, like in 20 seconds, we need 3 times higher than the previous one. Okay. Let's look at the efficiency. So here's a little story. When I came to the U.S., when I first time came to the U.S., I was shocked to see this kind of a bulb, light bulb. It said standard incandescent light bulb. But thing is, in South Korea, we usually don't use this bulb because efficiency of this bulb is pretty low. For example, if we put the 100% of power to light up, then it's light up, but the output light is only 5%. That means 95% or more is it's waste. Okay, so efficiency is pretty bad. It's just 5% efficiency. So we have a loss of 95%. Solar energy. Solar energy usually have a 28% efficiencies. That's pretty okay. Now it's getting increased, but 28% is still what we have. But let's say we have 2,600 watt from the sun. This is the power, and so power. If we have 28 efficiency, that means 72% of power will loss. Okay, so Actually, our house will take 750 watt. Then I'm just wondering that if we use this solar energy, it's very environmental friendly energy resources, right? There is no gas or no pollutions, so it's very clean. But if we want to use this solar energy to replace all the fossil energies in the United States, how much land do we need? Actually, Elon Musk, he is a CEO of Tesla and SpaceX. He made us presentation last year, so let's look at this presentation.
And most of that praise. And then you'll notice something, which is that there's quite a big difference in peak to trough usage. So the peak usage is typically at least twice the trough usage. So please bear that in mind. I'm going to reference that again later in the presentation. That's an important point. So what we're here to talk about is the solution. I actually think it's really a fairly obvious solution, but it's something that we need to do. And the solution is two parts. Part one, the sun. we have we have this handy fusion reactor in the sky called the sun. Okay, you don't have to do anything; it just works. Shows up every day and produces ridiculous amounts of power. Okay, now a lot of people aren't clear on how much surface area is needed to generate enough power to completely get the United States off of fossil fuels. Most people have no idea. They think that it must be a huge amount of area, like maybe you need these satellites in space, like space solar power. If anyone should be in favor of space solar power, it should be me. But this is completely unnecessary because actually very little land is needed to get rid of all fossil fuel electricity generation in the United States. That blue square there is the land area that's needed to transition the United States to a zero carbon electricity situation. It's really not much, and most of that area is going to be in rooftops. So you won't need to disturb land. You won't need to find new areas. It's mostly just going to be on the roofs of existing homes and buildings. So I really think that image is an important one to bear in mind when people are thinking about solar power. Like, how much will it take? Is it going to take something?
That was what we learned so far. So we learned what is the force and what is the difference between force and weight, mass, and pressure, air pressure, hydrostatic pressure, total pressure, energy, power, and efficiency. Alright, now we are going to look at Microsoft Excel. I think everyone has a chance to use this Microsoft Excel. I'm using this software every day since I was 20 years old. It's about 13 years ago. It's a very useful tool. So everybody knows about the Excel is used for the data input and make a table, and they have great functions to calculate the statistics, and also they provide very strong plotting functions using chart functions, right? 2D, sometimes line graph, very massive different kind of graph we can drawing using the Excel. So I think everyone can use this software, so I will skip this part. But I'd like to tell you that there is a function to calculate the mean and standard deviation, which is very important. Average and the standard deviation. This is the function. So you write this function using your keyboard and just select the range. This is data range. Then the Excel will tell you what is the mean and standard deviation. This is very simple. Okay. Let's look at one example that I developed. I used Excel in my research. My supervisor, Dr. Matt Reed, he suggested me to develop statistical model to predict the driving postures using their stature and weight and their seat configurations. So I developed a model, and I think I explained this concept before the previous class. Anyway, please look at these functions. It's very complex, and there are many input variables and the numbers here. So Matt suggested me, how about making some Excel spreadsheet so that we can just simply change the number, then the result will show up automatically. That's a great idea. So I create the Excel spreadsheet. You know, it can, if I change the seat height like 180 millimeter, and if I change some numbers, then the Excel will automatically change the position of eye location and hip locations using the based on the developed statistical models, which is applied into this spreadsheet, and the right image shows that it's continuously and at the same time it's real-time change. Okay, so it's very useful for seat engineer and some auto industry people using these statistical models. Today and continuously we learned about what is the mass, weight, force, density, amount, and temperature, and we learned the pressure, gas pressure, energy, power, and efficiency, and we had a chance to glimpse the Microsoft Excel. Thanks for watching this short video. Have a great day.